start Chapter 9 this way. We're going to start with a video. And it's the second to last chapter before the midterms. And then actually the last chapter, which is about gas laws, we're actually going to do part of the chapter before midterms, and part of it we'll do afterwards. So anyway, we've just finished talking about moles, converting mostly grams into moles, but also particles and liters, I understand. But, percent composition, which also was more grams to moles conversions, and hydrates, which is also grams to moles conversions, and finding the percent composition. But what was it all about? I mean, why did we really care about counting moles, which really is counting molecules, right? Because a mole represents a certain number of molecules. So if you count moles, you're counting lots of molecules, but you're still counting molecules. Why did we care? Well, for that, I need to actually go into cooking in order for you to understand it a little bit better. So above the line here, the title of the topic is this annoyingly large word, which really just means counting molecules in chemistry, and that is stoichiometry, or we can just call it stoic for short. And I want to know, and I want you to write here above the line, what information you get in a recipe. And this is part of your homework, is to write at least 3 or 4 things, types of information you get in a recipe. And what I'd like you to do after that, you can press pause if you have to, but I want you to take a fresh and blank sheet of paper out, and I'm going to show you something. So let's talk about a recipe for, let's make an easy one, chocolate chip cookies, okay? Or actually, we'll make it even easier. Let's just make it butter cookies, okay? So this is a butter cookies recipe. The reason I'm making it easy, just have very few ingredients. So let's see, let's do 1 cup of flour. Let's do, I don't know, a cup of sugar. Well, maybe half cup of sugar. A lot of sugar, isn't it? Well, whatever, who cares, I like sugar. Half cup of sugar. And we'll do, a half stick of butter. Not butter, but whatever, they're butter cookies, so fine. And maybe a 1/4 teaspoon of salt. And forget the instructions. We'll just say the yield is, how much it makes is, what do you want to say, 10? 12, 10 cookies. Let's make it 12 cookies. All right. This is really like stoichiometry. So if I write it as a chemical formula, right? So 1 flour. I know that the cup's there, but we'll care about that later. Half sugar plus half butter. You'll see where I'm going in a second with this. Half butter plus 1/4 salt. And that becomes 12 cookies. Okay. This is, in a way, the recipe. So let's just talk about what happens if you had 2 cups of flour. Let's say you had all the sugar you needed, all this butter you needed, all the salt you needed, and you had 2 cups of flour. 2 cups of flour could make how many cookies? Right, this is part of your homework, is to write down how many cookies you can make from 2 cups of flour. Write that down. All right, maybe I'll give you this one because it's important you see that in order to do the rest of this lesson. And that is that if you double the cups of flour, you're doubling the recipe. I told you have as much as you need of everything else, and so you're going to make 24 cookies. Probably not all that surprising, but you just did a stoichiometry question, because the ratio of flour to cookies is 1 to 12, and now I told you there were 2 cups of flour, and so you then were able to tell me that there would be 24 cookies. Again, if you didn't understand that piece, it's okay. Let's move on. Let's do the next question. How many cookies could I make if I had, let's see, a 1/4 cup of sugar? If I only had a 1/4 cup of sugar around, and I had as much as I needed of everything else, a 1/4 cup of sugar could make how many cookies? Answer that, and answer the same question for if I had 2 sticks of butter. If I had everything else in plenty of quantities, how many cookies could I make from the 2 sticks of butter? And this, again, is exactly what stoichiometry is going to be. So you could certainly do it back, your old way of like, oh, I double the recipe, so I double the cookies. And yes, you'd be absolutely right. And if you can see that, that's great. You could also do it by proportion. 1 to 12 equals 2 to 24. Also perfectly fine. Or 2 to x, I guess, because you would start there and then you'd cross multiply and do all the things you love to do. Either one of these ways is perfectly fine. So go back to your notes after you're done answering those other 2 questions, and let's go below the line, and let's extend this example to the tricycles. We did bicycle once, if you remember, when we did balancing equations. Now let's do tricycles. And let's see, we've got, how many frames? We've got 1 frame, and we have 1 handlebar. It's a tricycle, so we've got 3 wheels. Oops. It's not a tandem tricycle, so we're going 1 seat, and we're still going 2 pedals. When you add those up, you get a tricycle, which in compound speak would be FHW3SP2. If you were right, it's a chemical compound. All right. So now, what if you wanted to make 640 tricycles instead of just 1? How many wheels, how many W's would I have needed in order to make 640 of these? You go ahead, press pause, and do it your normal math way like you would have done it anyway. Go ahead. Okay, hopefully you came up with 1,920. That's fine. You should be able to show the work for that, and I'm expecting to see that work as part of your homework here, not just the number, but actually just, it's brief work, but the work. But even though you know the answer just by knowing it, I want to show you how we can use this right from the balanced equation, how we can get that. So a few ways to do it. I'll show you 2 ways right now. One is the proportion way. You've been told that this is the equation for making a tricycle. You've also been told that you want to make 640 tricycles. Now, of course, there is a 1 sitting here. And you also have been told that you want to know how many wheels you're going to need. So in a sense, that is your x. And if you see the way that this is set up, it actually is the proportion that you would set up. 3 over x equals 1 over 640. And that will give you the right answer. So that's one way you could do it. 3, and you should always write I'll do it this way just so I can underscoring reasonably well. You're doing it this way. You should always use your units. And the nice thing about this method is that it graphically looks exactly like the proportion does. 3 is over the x and 1 is over the 640, and that's exactly what you do here. Perfectly fine. You could also do this using factor labeling. So the way you'd start with is what you've been told, 640 tricycles. And even if you're not going to do this ultimately, you need to do it now. You need to multiply it by some fraction. That's going to give you, wheels. So think about what unit you need in the numerator, what unit you need in the denominator, how you're going to cancel things out, and what numbers belong there in order to get the wheels. And yes, you should come out with 1920. This, of course, can be extended into chemistry. Of course, just like with the oranges and the buckets that we talked about before, everything's working out just fine right now with recipes and tricycles. But when we talk about moles and molecules, it's going to all of a sudden, be a problem. But you'll come back to this and you'll do it this way. And you'll see that it's really the same thing. The calculation of chemical quantities is called stoichiometry. And we'll talk more specifically about that in class tomorrow. Thanks for watching.